we're going to look at some other things about triangles. Again, keeping it fairly basic, but there's one theorem here that's going to be pretty important that always seems to trip people up a little bit. So we'll take a little time with it. It's not this one. This is one that you all know. When you add up the three angles of a triangle on the interior, the sum is 180 degrees. Doesn't matter how big or small the triangle is, if it's obtuse, right, or acute. When I add up my three angles, the measure of angle A plus the measure of angle B plus the measure of angle C has to be 180 degrees. That's the way that works. You're pretty familiar with it. You've used it a lot. It's nothing new or earth-shattering. This is the one that kind of messes people up a little bit. And it's really not that difficult of a theorem. It's just people kind of struggle with it. But it introduces the idea of an exterior angle. And the exterior angle here is formed by extending a side of the triangle and then lining it up with a different side of the triangle. So here, segment AC is extended, and then the angle that makes with side CB, that is the exterior angle. And the theorem is this. It says the measure of an exterior angle is the sum of the remote or non-adjacent interior angles. So if I call this angle 2 and this angle 3, what it's saying is the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. Now, how do we know that that's true? Just a very quick reminder of the proof here, call that angle 4, that if I took measure of angle 4 to both sides of that little statement, angle 4 plus angle 1 together make a linear pair. That's 180. 2 plus 3 plus 4 together are the three interior angles of the triangle. That's 180. All I did is I took this and I subtract off the measure of angle 4 from each side. That's where this statement comes from. Linear pairs and triangle sum theorem to come up with that simple statement. And that turns out to be a really interesting little theorem that we use quite a bit in little algebra problems and stuff like that. Like this, for example, I have angle x and 70 and 2x minus 5. I need to know how to set this up. And this is a little bit tricky for people because it's not just x equals 70 or 2x minus 5 equals 180 or something like that. You have to think through the relationship. And this is a little bit different relationship. It's the sum of these two that equals the measure of this one. And then we go ahead and do our arithmetic. And I get x equals 75. Aha. So not quite the same as the other angle. So it's knowing the relationship and setting up the equation based on the relationship. Nothing new there. This corollary is relatively insignificant, but it does help us a little bit. If I know I have a right triangle where this angle is C, then the other two angles, measure of angle A and B, must add up to 90. Well, obviously, if I have 180 degrees in the triangle, and I use up 90 of them in one of my angles, that there's 90 left for the other two angles, which makes them complementary. Complementary means add up to 90. In a painting, the red triangle is right. The measure of one angle in the acute angle is twice the measure of the other. Find the measure of each acute angle. Well, so we're told it's a right triangle, and one angle is bigger than the other. It's twice as much. So this is my smaller one. I'll call that x, and that's 2x. Now, I could do this a couple different ways. I could use triangle sum and say 2x plus 90 equals 180. Could set that up. But we'll subtract that 90 off first, and I get 2x plus x equals 90. which is exactly what we were just talking about. The two acute angles, when I add them up, my two acute angles have to be complementary. They have to add up to 90. So I could start out with the whole triangle, but since we're given it's a right triangle, I could shortcut and use a corollary, jump straight to the second equation. Once I get this, that's 3x equals 90, so x is 30. Are we done? We asked this question many times this year. Are we done? Is that my final answer? What does it say? Find the value of x? No, it says find the measure of each acute angle. So that means this angle has to be 30, and this angle has to be twice as much, or 60. And then we call that a 30, 60, 90 triangle. Couple more problems with setting up the equations. Again, we need to know the relationship so we can set up the equation. It says for number 3, find the measure of angle 1. So in order to do that, I'm going to have to be able to figure some other stuff out, the value of x, namely, first. How do I set it up? Does 3x equal 40? Is that how we do about it? No, no. Is this automatically going to be 40 over here because this one over here is 40? No. We're going to have to use one of our relationships. We have an exterior angle. And I go, oh yeah, the measure of the exterior is the sum of these two. So 40 plus 3x equals 5x minus 10. We do our arithmetic or algebra. Please just don't write down numbers like 3x and 10 under here without symbols that go with them, positive, negative, plus, minus, so we understand that you understand what you're doing. 50 equals 2x, so x is obviously 25. Ah, we're done. No. We're not done because it doesn't say find the value of x, it says find the measure of angle 1. In order to find the measure of angle 1, I'm going to have to plug this 25 back in somewhere, either here or here, to figure out what that angle is, and then use that to build up to find my measure of angle 1. I'm going to just go ahead and plug it into this exterior angle, so that's 5x, or 5 times 25 minus 10, which is 125 minus 10, or 115. So this angle is 115. Now I know these two have to add up to 180, so measure of angle 1 has to be 65 degrees, because 115 and 65 is 180. Find the measure of each acute angle. Again, we're given it's a right triangle, so that's 90 degrees used up already. So these two added up have to equal 90. So 3x minus 6 equals 90. So 3x equals 96. Remember, we're adding 6 to each side, so be careful. So x equals 32. If x is 32, that means this angle is 2x, or 64. And this is 32 minus 6, or 26. Checking 90 plus 64 plus 26, yeah, that does add up to 180. So that's using it. And that's the kind of thing you're going to be expected to do in the homework tonight. Again, not too terribly tough, but the exterior angle theorem is kind of a new thing. So please take your time with it. Always make sure you're answering the questions that you're asked.